Today in our class we'll be learning about the medium of propagation of sound, children. We know that sound travels through solids, liquids and gases. And the speed of sound also depends on the medium, children. So propagation of sound through air, if you see, we know that air is a mixture of gases, right? So examples are, we can hear the sound of a train moving or glass breaking or firecrackers, and it all happens because sound reaches our ears through air. One more example is that you know that somebody is there outside your house when you hear the doorbell ringing. So how does this sound travel, children? So between the doorbell and your ear, there is a medium surrounding, which is nothing but air. So here the sound travels in the form of waves and reaches your ear, children. We also know that sound travels through liquids also. For this, a simple experiment, you can try this at home. Take a bell and immerse it in water. See to it that it doesn't touch the base of the tumbler, and then start ringing it. Ask your friend to listen if he can hear any sound that is produced by the bell. Yes, surely he will be able to listen to it. So here the medium of propagation is water, isn't it, children? And we know that a doctor listens to our heartbeat through stethoscope. And do you know what is the medium of propagation of sound here? So here the medium of propagation of sound is through solid, children. The sound of the heartbeat travels through the solid tube and reaches the ears of the doctor, right? And this one more example, you can try it for yourself. Ask your friend to be on one side of the wall, and on the from the other side of the wall you can hit the wall by using something like a bat or so, and the other person who is standing on the other side of the wall will surely be able to listen to the knocking sound. Yes? So now we know that sound travels through different media like solids, liquids or gases. Can sound travel through anything and everything? The answer is a no, children. Sound cannot travel through vacuum. Now what is vacuum? So a vacuum is a place from which all the matter is removed. There will be absolutely nothing, no state of matter in vacuum. So we know that sound does not travel through vacuum, children. It requires a medium for its propagation. A medium can be solids, liquids or gases. So we will be now learning how the sound actually travels. What happens to the particles of the medium now? Because they need a medium for its propagation, the sound wave is actually described as a mechanical wave, children. What is a mechanical wave? A wave that requires some material medium to travel. Sound also requires a medium to travel, hence it comes under a mechanical wave. To understand properly how a sound wave propagates through a medium, we must have an idea about the types of the mechanical waves, children. So there are actually two types of mechanical waves. One is longitudinal waves and the other one is transverse wave. What is a wave, children? It's nothing but a disturbance that is created in a medium. So we can understand more about wave by looking at this example, children. You can see that clear water is taken in a clear glass straw and waves are created, ripples are created using an artificial wave creating machine. So you can see just by observing the motion or the wave, we feel that the water is actually moving from one point to another. But when you place one lightweight cork ball or plastic ball, you can see that it just moves or oscillates up and down, but it actually doesn't move from one end to the other. It shows that the particles of the medium do not move from one point to the other, and it is just the disturbance that moves from one place to the other. Such waves are called as transverse waves because the particles are vibrating perpendicularly to the direction of propagation of the disturbance or wave. You can see here a similar kind of wave can be produced in a spring too by moving it up and down. That is called as transverse wave, children. Now you can see that Another type of wave can be produced using spring, and in this case you can see that the particles of the medium are vibrating in a direction parallel to the disturbance of the medium. Can you see this ball moving sideways, not upside down as in the previous case? So you can see the top one is called as a transverse wave, where the particles are moving up and down, and the below one is called as a longitudinal wave because the particles are moving side by side. So here are the examples, children. Ripples on the surface of the water are transverse, whereas sound waves are longitudinal waves, children. So we'll be learning more in our next lesson. Earthquakes are a mixture of longitudinal and transverse waves, children. Okay?